A transmitter is transmitting a signal. It need to transmit that one to a far distance receiver. As the signal is getting transmitted for the farthest distance, the signal strength is getting attenuated, and the receiver may not receive the signal properly. But the receiver, if the signal strength is getting attenuated as the distance increases, it is not good for that particular signal. So what we need to do, as the signal getting attenuated, it need to be amplified such a way that when the receiver at the other end has to receive the proper signal. For that purpose only we go for the amplification. So a simple statement is an amplifier circuit increases the signal strength. Example is your FM radios, example is your TV channels, or any communication uh, area. The signal is getting attenuated as the uh, distance increases. Even satellite communication also. Sometimes satellite communication, even though we are using satellites, the distance is very far away. You may get attenuated, even it may be destroyed also. So it may become zero. So before it's getting attenuated, it needs to be amplified. That is the purpose of using an amplifier. But while amplifying, it just increases the strength of its input signal, whether it contains the information or some noise along with information. That is the major issue with respect to amplifier. Whatever the signal it is received, simply it increases that one. Simply it increases the strength of that one. It may be having the actual information, it may be having the additive noise also because of the surrounding areas, because of the environmental issues. So amplifier actually it increases the strength. This noise or some disturbance is introduced into the amplifier because of the strong tendency to introduce hum due to the sudden temperature changes or stray electric and magnetic fields. There are different noises are there. We call that one as a Gaussian noise, white noise, and also thermal noise. As the temperature increases, there may be a noise comes into picture. Say a simple example is my class itself. I am transmitting my signal, an audio and also a video, and you are sitting in the other end. You may be sitting very close to me, or you may be sitting very far away from me, but the signal has to reach you. It may be some delay will be there. The signal has to reach you in a proper strength. Yeah, good. I'm getting good number of people who are joining over there. Let me continue. So, therefore, every high gain amplifier tends to give noise along with the signal in its output, which is very undesirable. What happens? Signal along with the additive noise due to various reasons like temperature increase variation, there may be white noise or Gaussian noise or some other issues. You will be getting, even it may be some physical parameters also they may get, they may add the noise itself. So all this noise we are not supposed to receive at the other end. It is undesirable. To avoid this noise level, the noise level in the amplifier circuit can be considerably reduced by using the negative feedback. See here, negative feedback. Usually there is a feedback. There are two different types of feedback amplifiers are there. One is the positive feedback amplifier, other is the negative feedback amplifier. We'll see to that one later. So the negative feedback uh, operation will nullify, or it will considerably reduce the noise which is there inside in the signal, done by injecting the fraction of output in phase of the opposition to the input signal. So principle of the feedback amplifier, I hope everyone is able to view the screen. This is already in the previous class also explained, but I want everyone to have a clarity in this one. See, sorry. See the diagram here. Here beautifully it's been explained compared to the previous circuit what I have explained. Okay. In that one, they have a simple block diagram they have given, but here they have clearly mentioned that one how exactly a amplifier and also a feedback system is going to work here. We have a signal called Vs, that is source signal. We are considering it here it as a voltage. So source voltage is there. Source voltage is initially fed to your amplifier, and amplifier is generating the amplified signal called the V naught. So that is a simple amplifier. It is whatever the signal is available, input signal is available, that has been fed into the amplifier, and amplifier simply amplifies it. It doesn't know whether it is having the actual signal or desired signal, or it may be having the some additive noise also. Simply it amplifies it. But I don't want the effect of the noise in my output signal. So what I will do, the negative, the whatever the output I got it, that will be fed back to the amplifier inputs once again using the feedback circuit. Using the feedback circuit. The bottom block diagram, what we are having, that indicates that when it takes the V0 as the input and it will add the feedback factor, means it will multiply the feedback factor, and the output of the feedback block will be once again fed back to your amplifier, so that a negative feedback will be given, which is been given as VF. VF is the product of the feedback factor with respect to the V0. That is, whatever the output voltage is generated from the amplifier, that will be fed and will be multiplied by the feedback factor, and the product of both of them we call this a VF, that is feedback voltage, that will be fed to the amplifier once again, which will be considered as a VI itself. So this diagram, if you are able to thoroughly go through this one, then it will be easy for you to explain each and every step of your feedback amplifier. So the feedback circuit usually consists of a resistors. The concept of feedback amplifier can be understood from the following figure. So this is what the following figure. From the above figure, the gain of the amplifier is represented as A. So here they have given clearly, they have explained the each and every parameter what we have. Again, amplifier gain is A. I hope everyone is able to see the most pointer what I am giving here. This is A is the amplifier gain, and beta is the your feedback factor. Beta is the feedback factor. The gain of the amplifier is the ratio of the output voltage V0 to the input voltage Vi. That means A is V0 by Vi. A is the gain, which is simply given as V0 by Vi. The feedback network extracts the voltage Vf, that is Vf, the feedback voltage, which is equal to beta into V0 from the output voltage of the amplifier. From the output voltage of the amplifier. So whatever the output voltage we are going to get from the amplifier, that will be directly fed to the feedback block, which has been multiplied by beta, and you are going to get Vf itself. This voltage is added for positive feedback and subtracted for the negative feedback from the signal voltage Vs. That is Vi, the input voltage what we are giving for the amplifier, that is this Vi, which is the summation of these two, Vs plus Vf, Vs plus Vf. That is what the equation they have given. So Vi, which is the input signal for the amplifier, which is the summation of the source signal Vs and also the feedback voltage Vf. The feedback voltage is basically what? It is beta into V0. So clearly it's been given Vs plus beta V0 we are going to give. This is for the positive feedback amplifier, and this is for the negative feedback amplifier. See here, clearly when you're writing about the feedback amplifier, you have to indicate that when Vi is equal to Vs plus Vf for the positive feedback, and Vi is equal to Vs minus Vf for the negative feedback itself. Okay, the voltage is added for the positive feedback and subtracted for the negative feedback from the signal voltage Vs. The quantity beta, which is equal to Vf by V0, is called as feedback ratio or the feedback fraction. Feedback ratio or the feedback fraction. So clearly it has been mentioned. Let us consider the case of negative feedback. The output V0 must be equal to the input voltage Vs minus beta V0. That's correct. Okay. The output V0, which is equal to Vs minus beta V0. Beta V0 is what? It is Vf. So output what we are going to get V0, which is subtraction of the feedback voltage by the source voltage, that is Vs minus beta V0 they are given. Vs minus beta V0 multiplied by the gain. Okay. So Vs minus beta V0 into A is equal to V0. So initially it may be V0, but once it is fed back for the next time, it will be Vf. VF is basically beta V naught. So Vs minus beta V naught or Vs minus Vf into A, which is equal to the next V naught we are going to get. Similarly, multiply them, A into Vs minus A into beta V naught, which is equal to V naught. Then you take V naught in one side, then you are going to get V naught into 1 plus A beta. AA is AVS is equal to V naught into 1 plus beta. Therefore, V naught by Vs, that is output voltage divided by V input voltage, will be given as A divided by 1 plus A beta. So here is explained better than the textbook. In the textbook, directly they have given the equation. Here, step by step, they have explained about that. Any issues? Any clarification required here? Anyone? If you have any clarification, if you want any clarification, you ask. Or you can give a signal saying that one you got the concept. I hope everyone is getting the concept over here. Feedback amplifier. A simple, this much if you are able to write, you will definitely get the 4 marks easily. Charan, I could not hear you. So I think the concept is clear with respect to feedback amplifier, how exactly feedback amplifier will come and what is the gain of the amplifier, that is V naught by Vs, what's going to happen.
Yes,
Gain
sir.
A divided by 1 plus A beta. Let AF be the overall gain with the feedback of the amplifier. This is defined as the ratio of the V naught to the applied signal Vs. AF is equal to V naught by AS. So now this equation what we are getting, sorry, V naught by Vs, which is equal to AF. AF is equal to A into A divided by 1 plus A beta. So from the above two equation, we can understand that AF is equal to A divided by 1 plus A beta. This is for the positive feedback. Now similarly, we have to go for the, that is for the negative feedback. Now we have to go for the positive feedback. This above equation, what 1 minus A beta will be there. Okay, because you are changing the polarities over there. So definitely your output will come in the other side. So you're going to get 1 minus A beta. You can try substituting this. So it's the same equation. I will go once again go for it here in this equation. See here, Vs minus beta V naught is what we have given for the negative feedback. For positive feedback, what we have to give? Vs plus beta V naught into A is equal to V naught. AVS plus AB beta V naught is equal to V naught. Then this you have to take it on the right side. Okay. Other side, you're going to get Vs V naught plus A beta. This is what we were having in minus, but when you take it on the other side, V naught minus A beta V naught will get for positive feedback. So that is why 1 minus A beta V naught will come. Any confusion for positive and negative? Any confusion here?
No, sir.
Okay. So for negative feedback, it is the overall gain is equal to AF is equal to A divided by 1 plus A beta. For positive feedback, overall gain is equal to A divided by 1 minus A beta. Okay. So types of feedback. The next one, the process of injecting a fraction of output energy of some device back to the input is known as the feedback. That's what. What do you mean by feedback? What are the output we are having? The fraction of output energy that is fed back once again to the input. It has been found that feedback is very useful in reducing the noise and making the amplifier operator stable. Okay. Depending upon whether the feedback signal aids or opposes the input signal, there are two types of feedback used. One is the positive feedback and one is the negative feedback. The feedback in which the feedback energy, that is either voltage or current, is in phase with the input signal and thus aids it, is called as a positive feedback. What happens? That whatever the signal we are feeding back, that should be in phase with the input signal. Then only we will call it as a positive. If it is not in phase, both the input signal and the feedback signal introduce the phase shift of 180, thus making us a 360. I already told this one in oscillator also. No need to repeat that one. Whatever you are having, overall 360-degree phase shift you should have, then only will get positive. Though the positive feedback increases the gain of the amplifier, it has the disadvantage such as the increasing distortion, instability. So the main disadvantage with respect to the positive feedback is increasing distortion and instability. Increasing distortion and instability will be. It is because of these disadvantages, the positive feedback is not recommended for the amplifier. See, I'll go to the last part. Why exactly positive feedback? It's having increasing distortion and instability. It's not stable. Okay. It is because of this disadvantage, the positive feedback is not recommended for the amplifier. If the positive feedback is sufficiently lost, it leads to oscillation. Leads to oscillation by which oscillator circuits are informed. Oscillator circuits are informed. Okay, it leads to oscillation by which the oscillator circuits are formed. This concept we'll discuss, that is oscillator, we have already discussed over there, no need to check. That is with respect to positive feedback. But when it goes to negative feedback in which the feedback energy, that is either voltage or current, is out of phase. See here, it is clearly saying that one, it is out of phase. Okay, so in positive feedback, the signal is in phase, but in negative feedback, the signal is out of phase with the input and thus opposite. It is called negative feedback. In negative feedback, the amplifier introduces the phase shift of 180° into the circuit, while the feedback network is so designed that it produces no phase shift. See here, no phase shift comes into picture, okay, or zero phase shift. No phase shift in negative feedback. The feedback signal what we are having, it does not have any shift. It will be having a zero phase shift. Thus, the resultant feedback voltage VF is 180° out of the input voltage. So that's why we are going to subtract that. Though the gain of the negative feedback amplifier is reduced, it's not that much very high. It is having a stability and it also reduces the distortion. So see the advantages of the negative feedback. Stability of gain is improved, reduction in distortion, reduction in noise, increase in input impedance, decrease in output impedance, increase in the range of uniform applications. So n number of applications are useful for negative feedback. Okay, so this itself is going to fetch you very good marks whenever you're explaining about the types of the feedback, what is positive feedback, what is negative feedback, everything you can go for it. Let us go what else we are having. Okay, it is because of this advantage, negative feedback is frequently employed in the amplifier. So any clarifications? What do you mean by feedback amplifier? How exactly feedback amplifier is going to be used? Okay, negative feedback. When it look into negative feedback, we are going to have the negative voltage feedback, we are going to have negative current feedback, voltage series feedback, voltage shunt feedback, current series feedback, and current shunt feedback. So these are all the 4 types of feedbacks are there. Okay. So when you look into this particular web page, you're able to clearly know that one, what is shunt to series, what is series to series, what is shunt to shunt, what is series to shunt. 4 different types of amplifiers what we are having in the topic. Let us go one by one. Here once again it has been clearly said, negative feedback is an amplifier is the method of feeding a portion of the amplified output to the input but in opposite phase. Means there is no phase shift. Phase will not be in phase, that is the feedback signal. The feedback signal is not in phase with the source signal. Okay, not in phase. No phase is matching. The phase opposition occurs as amplifier for 180 phase shift, whereas the feedback does not, feedback network does not. So amplifier will be having 180 phase shift, but feedback will not provide the phase shift. While the output energy is being applied to the input for the voltage energy to be taken as feedback, the output is taken in shunt connection, and for the current energy to be taken as feedback, the output is taken in series connection. See here, if it is a voltage amplifier, then output is taken as shunt. If it is a current amplifier, then output is taken as series. So There are two main types of the negative feedback circuits. They are negative voltage feedback, negative current feedback. Basically, as we said, we don't prefer the positive feedback amplifiers. We always prefer the negative feedback amplifiers because of the so many advantages. So, negative voltage feedback, let us go one step by step. In this method, the voltage feedback to the input of amplifier is proportional to the output voltage. This is further classified into two types: voltage series feedback, voltage shunt feedback. But generally we go for voltage shunt feedback, we prefer. Negative current feedback, similarly we are going to have the current series feedback and current shunt feedback. Okay. So in voltage feedback, we take this voltage, it can be shunt feedback, it may be series feedback. Similarly, current also, it may be series feedback, it may be current shunt feedback. Okay. Let us see one by one. What do you mean by voltage series feedback? What do you mean by voltage shunt feedback? But the conclusion is, whenever you go for the voltage, shunt feedback is been preferred. Whenever you go for the current, series feedback is been preferred. Let us see how it is going to be taken. This is the diagram. Same diagram we are going to use everywhere. In the voltage series feedback circuit, a fraction of the voltage is applied in series with the input voltage through the feedback circuit in series. This also has shunt driven series feedback, that is parallel series circuit. Okay. The following figure shows the block diagram of the voltage series feedback, but by which it is evident that the feedback circuit is placed in shunt with the output, but in series with the input. See here, this is the output. Okay. This is the output. Okay. But feedback is kept in shunt driven. The same thing has been given over there. But it is, when it comes to your input, it is series. So we call it as, it is placed as output, that is shunt with the output and series with the input. See, if you have any doubt, you can clarify it now itself. Even though voltage series feedback, we say that when whatever we are feeding back, that is shunt with respect to the output, but series with respect to the input. It is shunt with respect to the output, but series with respect to the input. That is why you call voltage series feedback. Let us see how it. As a feedback circuit is connected in shunt with the output impedance is decreased, and due to the series connection with the input impedance is increased. Clear? On dot it is mentioned over there. Output is, because we are from the output end, it is shunt, the output impedance is decreased. But if it is in series, definitely the input impedance is increased. See, when you keep it in series, always one after the other, it has to pass through. What happens? The impedance is keep on increasing it. Okay. If it is shunt, all are parallelly. So we don't have one after the other. All are parallel, it's going to execute. So impedance is not playing an important role. They are very, very nominal in terms of the output impedance. But when it comes to series, first initial voltage, then after that one, the feedback voltage, like this, it has to one after the it has to do. So impedance is increasing. Now it moves to, we'll move to the voltage shunt feedback. It is shunt feedback. See the diagram here, how it differs. See the diagram, how it differs. See the diagram in the previous case. Just a second. Excuse me, am I audible? Hello?
Yes, sir.
Yeah, I got a call from the department. No issue. I will continue. So, see, you see the diagram here. See here. Here it is very, very important when it comes to voltage series feedback. Voltage is fed in series. Voltage is fed in series here. Okay, fed in series. Here it is shunt. Here it is shunt. But here, when it comes to here, it is in series. But when you go for voltage shunt feedback, see the difference. Here also it is in parallel. Here also it is in parallel. Both the side it is in parallel over there. Okay, that is what voltage shunt feedback will call it. In this voltage shunt feedback circuit, the fraction of the output voltage is applied in parallel with the input voltage through the feedback network. That is why we call shunt driven shunt fed. That is shunt series what I have told. No, series shunt series shunt shunt. So this is shunt feedback will call shunt driven shunt fed. Driven is also shunt, fed also shunt in this case. Okay, so the below figure shows the block diagram of the voltage shunt feedback, by which it is evident that the feedback circuit is placed in shunt with the output and also with the input. The feedback circuit is placed in shunt with the output also, in shunt with the input also. You have to draw this one properly whenever you're writing your answers. So if you're missing, even if you are misplaced, here it's supposed to be jump wire is jumped, or the wire is not connected. Here also wire is not connected. So this to the bottom, top line is connected to top. So but operations are same. Gain is the A is the gain of the amplifier, beta is the feedback factor. We are going to have all those operations same only will go to. As the feedback circuit is connected in shunt with the output and the input as well, both the output impedance and the input impedance is decreased. Whenever it is shunt, impedance is decreased. Whenever it is series, impedance is increased. Okay. Now we'll move on to the current feedback, current series feedback. See here, series. Output side also is series, input side also is series. Okay, series driven, series fed. Series driven, series fed. That's why we'll say series. I told you voltage is in shunt, current is in series. Okay, series. Here is called series driven, series fed. We'll call that one directly. Simply we can understand it as the feedback circuit is connected in series. Whenever it is series, obviously it is impedance is increased. Whenever it is shunt in the both side, the resistance or impedance is going to be increased. Shunt, it is decreased. Series, it is increased. So the last type, current shunt feedback, that is driven is series, connected is, that is fed back is shunt. Don't have any confusion. Clearly it is mentioned. If you refer this particular material, it will be easy for you to explain all the amplifier application, that is feedback amplifier applications. So series driven shunt fed, series driven shunt fed is only. So since your output is in series, that is it is output impedance is more, and input is in shunt, input impedance, that is input side feed is feedback is in shunt, so input impedance is in decrease. Input impedance is decreased, output impedance is increased. Okay, output impedance is increased, and due to the parallel connection with the input impedance is decreased over there. So now when you go for the characteristics, the same thing has been represented in the form of the table. Voltage gain, voltage series decreases. Okay, in all the thing it decreases. Bandwidth in all the four cases increases. Input resistance, you should know, if it is in shunt fed, input resistance is decreases. If it is series fed, then input resistance increases. So voltage series increases, decreases, increases, decreases. Wherever is series, input impedance is increases. Wherever is shunt, input impedance is decreases. Similarly, output resistance, wherever is series, it is increase. Output resistance showing decreases. Okay, yeah, decreases, decreases, increases, increases. That is output resistance. You're going to have decreases, decreases, and increases. Harmonic distortion, noise also. In all the four cases, noise is going to be decreased. Feedback purpose is what? To decrease the noise. Whichever the type of the feedback amplifier, we are going to decrease the noise itself. So, any clarification is required here? Any clarification? We are having feedback amplifier, we are having the series feedback, we are having the shunt feedback, we are having the voltage shunt feedback and voltage series feedback, current series feedback, current shunt feedback. What do you mean by shunt? What do you mean by series? You should be thoroughly, you should explain that. If that is the case, then your topic will be over. So this much if you read, it is more than enough for currently. I want everyone to refer this particular tutorial point where you are able to get all the questions. So you can go for all these things like noise amplifier, amplifier useful resources, amplifier quick guide, amplifier useful resources, amplifier discussion. Emitter follower, Darlington amplifier, everything has been given. That is for extra. If you want more information, it will be useful. Don't think that it is not useful, it will be useful. Maximum 10 to 15 minutes. If you read, it's more than enough. What do you mean by emitter follower? Source follower, emitter follower, we have given no source follower in your FET, but in BJT we'll call this a emitter follower. See here, it's going to be 1, the beta. That is why we'll call this a emitter follower. It's not required. If you want more information, you can go for it. They are not given with respect to, see, they are given the equivalent circuit. They replaced your transistor and they given the equivalent circuit. The same thing. RE dash is there. RE dash is there. With respect to, I don't want you to get confused because here it has been given with respect to transistor, that is BJT. Let us not go for it. We'll go for only everything has been given. Amplifier. What do you mean by amplifier? Let me check it out very quickly. Could not find any courses. Any mistake? No, we are not getting anything about the FET. MOSFET. Let me check. No, we are not getting anything. So they are mainly given. Sorry. Any clarifications? Any questions? No, it is open for questions and answers. Anyone, any questions? I hope with this, if you refer, if you read, if you write, I suggest you to write this one. All the circuits, what we are having, feedback circuits, positive feedback circuit, negative feedback circuit, and series, voltage shunt, current series, current shunt. If you write, practice this one, definitely you will get full marks. Okay. If any other thing I need to give, I will be sharing with you in the group itself, what and all you need to study. Shall I wind up? Sharan, you want to say something?
Point notes you send in Teams, sir.
Which one?
Tutorial point. This notes, sir.
I've already shared in WhatsApp link also. Check it out in WhatsApp also. I shared with you in Mangalyan group. Check. Yes, I already shared feedback. Refer feedback amplifier. I think spelling mistake is there. AMP supposed to be given. You just click on the tutorial point, you will get it. Anything else?
Nothing, sir.
Okay. Anyone else? Any other questions from your end? Any other clarifications? I think there was no glitch in the network, no glitch in the audio, video. Everything is okay now?
Yes, sir.